All right, so we will talk about the 12.4 homework now. And so in 12.4, we kind of drew this picture, and I'm going to come back to this picture for the videos that we do for the problems we do in this video. And then I'll make a second video for z-scores. Okay, so if you haven't created this for your notes, go ahead and do that. You can pause the video and do it. Basically what I did is we took the mean, and then from the notes we learned that 68% of all data lies within one standard deviation. That is the mean plus one standard deviation, or the mean minus one standard deviation. And then if we go further out, 95% of all data in a normal distribution lives within two standard deviations. And so that's what we have here. And for each of these, I broke them down into half. Since it's symmetric, then 34% lives between 1 minus 1 standard deviation, and 34% lives between the mean plus 1 standard deviation. And we can continue that. And so in each of these little rectangular partitions, if you will, that tells us how much of the data is in each one of those. Okay, so I'm going to come back to this picture to answer the problems in the homework. You could, on the test, after you start the test, you could create this and use it for these problems. All right, so let's just start. The first one I'm going to look at is, I think, number 11. So the first one we're going to look at. So if you look at the problem, that graph is the same as this graph. And in the problem, in the few problems we're going to do, they're going to ask you the question, and it'll be with all these numbers. Now, we don't have to do any calculation using those numbers. We just need to know how far away from the mean they are and which partitions we're dealing with. I labeled them with Roman numerals. You could do whatever you want. All right, so let's just read this. It's common knowledge that you're not always going to pay the full price for a car. And so that's what it's telling us. Not everybody pays the same price. And in fact, the questions we're going to look at using this picture kind of take this concept, so we won't have to reread it every time. For this problem, the mean is 24,000 and the standard deviation is 2,000. That means that this 24 is our mean, and then if I go 2,000 in either direction, that is one standard deviation. That way and that way. Two standard deviations would be 2 more thousand, okay, and so on. What's a little deceptive about these pictures is it looks like it stops at 18 and 30. It doesn't, it keeps going. That represents this kind of excess on my graph. So the question is, the percentage of buyers who paid between 20,000 and 28,000. So I'm going to mark it. 20,000, 28,000, and look, that's 95%. And so that's all we got to do. Notice they already have the percent, 95%. Now, they're not all that easy. We may have to do a little bit of calculations of what part, but that's the concept. Number 12, we'll do the same thing. Number 12 is the same question about buying a car, except now my median or my mean is 18. Same thing, it says the mean is 18,000, standard deviation is of 1,000. So each 1,000 would go out. And it says use the 68, 95, 97.99.7 rule to find what percentage of buyers paid between 18 and 19. I need to now label or highlight 18 and 19. All right, well, look, 17 to 19 would be 68%, but I'm only taking half of that. So 68 divided by 2 is 34%. In my picture that we drew, that's where we get the 34%. Okay, we're only concerned about the right side of that 68%. We're only concerned about this right here. Okay, so that's half of 68, which is 34. So once you see that graph, once you have that graph, things are so easy. All right, 13. Let's see what they're wanting us to do here. The figure illustrates a normal distribution for the prices of the car. All right, the mean is 14 grand. The standard deviation is only 500. Okay, fine. It wants us to figure out what percentage is between 1250. I'll go and find 1250 and 14,000. Okay, well, 14,000 was my mean. So in this case, this little line lines up to 99.7. The mean here is 14. That kind of cuts through the middle of the 99.7. So we're going to take the 99.7, divide it by 2. Okay. So it's approximately 100, obviously, but they're going to want you to round. Well, they don't tell you to round. So we're going to take whatever we get and put the exact number. So 49.85. 49.85. All right. And this is all we're doing for the first half. Then we got to do the z-scores in the next video, which is also pretty straightforward. Right? I'm skipping 14 because it's just like 13. Number 15, let's see, same idea. We've got the cars. What percent is between 20,000? Oh, no, this one's different. This one says who paid less than 16,000. Okay. Well, here is 16,000 right there. So I want that and all of this. And I know my graph isn't all of that, but this is all the stuff we're looking at. Okay. So, well, I think what I'm going to do, I'm going to refer back to my table here. 16,000 is, let's see, there's my mean. So 16,000 is the 2 standard deviations. Let's double check that. Mean is 20. So 1 standard deviation, 2 standard deviations. So what I need to do is add up everything here and here. Okay. So if I go to mine and I go to the 2 standard deviations, here I am. I'm going to add up the 2.35 and the 0.015. In fact, I want to label it on here. Let's see, that's 2.35 and then 0.15. I'm going to add those 2 numbers up. 2.35, 0.15 is 2.50. And here I can write the 2.50 or just 2.5. So we're using this table. We have to do a little bit of thinking. That's okay. All right, so what if the example like 18 and 19 does not have a picture? Well, nobody's stopping us from drawing a picture, so I might do that. All right, so number 18. Scores on the GRE are normally distributed with a mean of 500 and a standard deviation of 84. So here's what that's telling you. You draw your standard deviation. No one's going to count off if it's not looking great. The mean is 511. The standard deviation is 84. So I'm going to add 511 plus 84 is 595. Just so you know, this was 511 plus 84. That's my mean plus 1 standard deviation. And I'm going to do that again. I'm going to subtract it. I'm going to do 511 minus 84. That's 427. Okay, this was the mean minus 1 standard deviation. Okay, that means that in this region, 68%, I'm running out of space, 68% live there. Okay, in all of this, 68% lives in all of this. Now, I didn't even read the question. I just kind of started working. But I wanted to show you when they give you these numbers, how we can construct our table like this. And we can put the numbers in there. So like this is 34%. This is 34%. Altogether, it's 68%. So let me actually see what they want. I jumped the gun and turns out that's what they want there. The percentage of people taking the test who score between 427 and 511 is what? Okay, so 511 is your mean. 427 is here, so between 427 and 511 is only half of that 68, and it is the 34. Okay, so I'm going to make my next picture larger because I feel like I need more space, but that's the idea. So we're going to do number 19, and then I'm going to stop this video, and we're going to do the z-scores problems. Be a little faster, I believe. All right, so let me draw this. I know that's what I got to do. It's not pretty. That is pretty ugly, but it doesn't matter. Here in the middle, that's my x bar. It says, in this case, my mean is 502. And the standard deviation is 94. So let me go ahead and do 1 standard deviation. Okay, so 502 plus 94 is 596. And then 502 minus 94 is 408. This was 68%. I'll do that. I'll just use my yellow highlighter to indicate that this is 68%. Okay, that's 34 and 34. So I knew I needed to go at least 1 standard deviation, but let me read what they want. They want to know what percentage of people score below 408. Well, there's 408. That means I need to add up everything less than 408. So I'm going to use another highlighter to look at what I'm looking for. I need to know all of this. It actually kind of goes on forever. I could do this a couple of ways. I'm going to show you how I can refer it back to my chart. The 408 is 1 standard deviation. This was x minus 1 standard deviation. Minus 1 standard deviation. That's hard to read. X bar minus 1 standard deviation. All right. So I need to add up all of these little numbers to the left. Okay. So all of this, all of that, and I'm getting these numbers from this, is 13.5 plus 2.35% plus 0.015%. So we're going to add those up and see what we get. Okay, if I add all of those numbers up, I get 16%. Now, that's one way to do it. I could have recognized that everything from the mean to the left is 50%. I could have done 50% minus 34% and gotten 13. Okay. Or I could have done 50%, since that's half of everything, minus 34% is 60%. So whichever you like is fine. You may need to draw this out a few times. It helps me see it, but it's up to you. All right, so let's stop this video, and we will do z-scores in the next one.